All right, let's do this lesson on quadratic applications. So the idea here is exploring some story problems that can be solved using quadratics. I found that there wasn't enough space to work on this note page, so I reprinted each problem and put them over here, but I'm showing you this just so that you can see that this is from lesson 8-3. Okay, the first problem says this. The width of a rectangle is 6 meters less than its length. If the area of the rectangle is 112 square meters, find the dimensions of the rectangle. So there's a lot to unpack in there, and let's start with the fact that the shape we're dealing with is a rectangle. The longer side is usually called the length, the shorter side may be the width. They mentioned area in here. So we might want to recall that we have learned in the past that area of a rectangle is equal to the length times the width. Right? If we were to create square boxes out of this and count up all of the squares that are in there, there would be 112 square meters inside of this area. Sorry. Okay, so let's find out what we've got here. This says the width of a rectangle is, that's a key word often when we're looking at mathematics story problems, is usually indicates to us that we want the equal sign, is 6 meters less, so I'm going to subtract 6 from something, 6 meters less than its length. We know that the length is just L, so I'm going to say, okay, the width must be the length minus 6 meters. If the area of the rectangle is 112 square meters, find the dimensions. Okay, we have an expression for the length, L. We have an expression for the width, L minus 6. The advantage of these is they both just use the letter L, so that's nice. We can solve for one variable pretty easily. So I'm going to multiply them together. Now, it's tempting for students to do something like this, L times L minus 6. But because this has two terms, we need to be careful to use parentheses around the L minus 6 so that we're multiplying genuinely the entire binomial, not just the first term of it. Okay, the length times the width, L times L minus 6 equals the area, and the area in this case is 112 square meters. Okay, so let's solve this quadratic. We have L times L is L to the second power. L times negative 6 is negative 6L equals 112. Let's put this in standard form by subtracting the constant from both sides. So we have L squared minus 6L minus 112 equals 0. Now, I'm not sure if this one factors. It might, so I'm going to check it out. So what I'm doing is taking my calculator and trying 112 divided by maybe 4, and I get 28, so I need to go higher. 112 divided by 6 doesn't work. Divided by 8 is 14. 8 and 14 are 6 apart from each other. So these are two good numbers. If I multiply them, I get 112, but one of them needs to be negative, so that when I multiply, I get negative 112, but also so that when I add them, I get negative 6. So I think negative 14 is going to be the one that we want. So now I list the factors that we found. L plus 8 and L minus 14 equals 0. Okay, based on this we can solve. I'm looking for some value that when I add it to 8 it equals 0. If I find that number, then I've got 0 times other stuff and it equals 0. So I will have solved it. 0, let's see, what plus 8 equals 0? I think it's going to be negative 8. Negative 8 plus 8 equals 0. And what minus 14 equals 0? That one's going to be 14. Okay, we have two answers because it's a quadratic. Sometimes one of the answers doesn't fit the story. So let's take a good glance back to remember what we're talking about. L stands for the length of a rectangle. If the length of a rectangle is negative 8 meters, that doesn't really make sense. When people are talking about the length of anything, they don't talk about it in negative terms, right? I wouldn't say, please go make a poster that's negative 2 feet by negative 3 feet. It just doesn't make sense. So we're going to disregard the negative answer. Sometimes that happens in quadratics. We have two answers and only one of them made sense. If L is 14, That means the length of the rectangle is 14 meters. Can we find the width of the rectangle? There are two things that can guide us here. First off, we wrote an expression about what the width is. We said it's the length minus 6. So if the length is 14, we can take 14 minus 6 and we find out what the width is. Another way we can do it is say, okay, 14, that's our length. 14 times something equals our area of 112. So we could take 112 divided by 14. And that would also lead us to the width, which we should get the same answer in both cases. I'm just going to double check with the calculator. Yeah, it's 8. So the length is 14 meters and the width is 8 meters. Okay, it may be tempting here to say, oh, look, we got the answers, sort of 8 and 14, but that was a coincidence. The fact is that sometimes we have to just throw away one of the answers, so don't get into the habit of thinking that both answers are actually what we want. This was a coincidence in this case. It won't always happen like that. All right, let's try number 2. The hypotenuse of a right triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. Okay, we can't read a story problem like we're reading a novel or an interesting book because it has too much very specific information. So it should be read more like when you're reading maybe a dictionary or when you're reading instructions on how to build a bookshelf or desk or Christmas toy or something like that, okay? We need to pay attention to each word along the way. But let's remind ourselves of the things that we do know. It's talking about a right triangle, so you might be able to draw yourself a right triangle. I think I could maybe do better than that. Okay, pretend that that's a perfect right triangle. The hypotenuse of the right triangle is the longest leg, the longest side, I should say, and it's opposite the 90-degree angle. So that's our hypotenuse. The other two sides of the triangle are called legs, and we have a short leg. I'm going to call it X. If I call it S, my S looks kind of like a 5, so I'm going to do an X instead. And the long leg is L, and I'm just going to use a capital L because then it doesn't look like a 1, which lowercase l does. Okay, now let's read into this and see if we can figure out what to use. It says the hypotenuse of a right triangle is, so I'm going to put equals by H, 1 foot more. 1 foot more means I need to add 1 to something. 1 foot more than twice the length of the shorter leg. Twice the length of the shorter leg means that we're going to take the short leg and multiply it by 2. We're going to double it. Students are often tempted when they see twice the length of something to square it, especially because we're in quadratic units, and I can understand their confusion, but if we square something, we don't get twice what it was. For instance, if I have 6 and I square it, I get 36. But if I get twice what 6 is, that's 6 plus 6, that would be 12. So I'm taking 2 times 6, that would be twice 6. Okay. So we've got an expression for H using the shorter leg. Let's see where else we're headed. We can change colors for a second. Okay, the longer leg, that's the one we're calling L, is, okay, another equal sign, 7 feet longer. 7 feet longer. So I think I'm going to add 7 to something. 7 feet longer than the shorter leg, and we were calling the shorter leg X. Find the dimensions of the triangle. Okay, so we have a hypotenuse with an expression of X. We have the short leg, expression of X, and we have the long leg, also has an expression of X. So one variable in all these places. That's going to be nice. They didn't provide us with a formula. They want us to rely on what we know. And so there is something called the Pythagorean theorem that's going to come in handy here. And that is, for any right triangle, if you take and square the legs and find their sum, it is equal to the square of the hypotenuse, which is actually a pretty cool and remarkable thing, but we're going to use this to our advantage. So what I need to do is square each of the parts. I'm going to square the short leg, I'm going to square the long leg, I'm going to square the hypotenuse. So this is going to take a little bit of work, but then we can put them together to solve for x. Okay, so the short leg is x. If I square that, I get x squared. Short leg done. The long leg is x plus 7. If I square that, it's going to be x plus 7 times x plus 7. Notice the use of parentheses again because we had two terms. So I'm going to take x times x. That will give me x to the second power. X times 7 plus x times 7. That's going to be 7x plus 7x, so 14x total. And then 7 times 7 is 49. Okay, we've squared the long leg. Finally, we need to square the hypotenuse. And the hypotenuse had the expression 2x plus 1. I need to square that. And again, because it's a binomial, two terms, I need to use parentheses. So 2x times 2x is 4x to the second. 2x times 1 is 2x. 1 times 2x is another 2x. So I'm going to take 2x plus 2x, I'll get 4x. And then 1 times 1 is 1. Okay, I've squared each of the parts. So it's like I have a squared, I have b squared, I have c squared. Short leg, long leg, hypotenuse. Now, according to the theorem, what I need to do is add the legs together and set it equal to the hypotenuse. So let's do that. I'm going to take x squared plus 14x plus 49 and set it equal to 4x squared plus 4x plus 1. Okay, let me rewrite the expression that we have on the left. X squared plus x squared is going to be 2x squared plus 14x plus 49. And on the right we have 4x squared plus 4x plus 1. I want to bring all the terms over to one side. I like to have a positive leading coefficient. So I'm going to take the smaller out of these two and move it. I'm going to subtract the 2x squared. While I'm at it, I'll subtract 14x from both sides and 49 from both sides. That way I'm closer to standard form. I'll have 0 equal 2x squared minus 10x minus 48. Okay, I'm noticing that each term is even, so I'm going to divide everything by 2. 0 divided by 2 is just 0. 2x squared divided by 2 is x squared. Negative 10 divided by 2 is negative 5x. And negative 48 divided by 2 is negative 24. Now I'm going to see if I can factor. So I take a, which is 1, times c, negative 24, and then put b on the bottom. I'm looking for two numbers whose product is negative 24. So when I multiply these two numbers, I'll get negative 24. But if I add the numbers, I will get negative 5. Okay, so if I take 24 divided by 1, that won't do it. 24 divided by 2 would give me 12. That has a difference of maybe 10. 24 divided by 3 is 8. The difference between 3 and 8 is 5, so those might be the ones. I know that 3 times 8 is 24, and if one of these is negative, I can subtract and get 5. Now I have to be careful about which one I make negative because I want to make sure I get negative 5. So I think it needs to be the 8. If I do the larger number, negative 8 plus 3, I'll get negative 5. So these are our factors. All right, so we have 0 equals x plus 3 and x minus 8. Okay, we've done this just recently, right? We said, okay, take these two and we want to solve. So what value for x is going to make that equal 0? It's going to be negative 3. Negative 3 plus 3 is 0. What value for this x is going to make that factor equal 0? And that one would be 8. If we do 8 minus 8, we'll get 0. So we got two answers out of this. We don't always use two answers, so let's glance back at the problem. It said, find the dimensions of the triangle. One of the dimensions, the short leg, is x. So, would a dimension of negative 3 make sense in our triangle? No. Negative 3 doesn't make sense. So I'm going to use instead the dimension x equals 8. That fits the triangle. So the short leg, x, has a dimension of 8. We don't know what units. Oh, feet. I'm picking that up from over here in the problem. Okay, 8 feet. The longer leg is x plus 7. So if x is 8, then x plus 7, that's 8 plus 7, so we're getting 15 feet there. And for the hypotenuse, we said that that was 2x plus 1. If x is 8, then we've got 2 times 8, 16, plus 1, that's going to be 17 feet. I don't think it's a bad idea to check the work that we've got and make sure that it fits. So what I'm going to do is use this in the Pythagorean theorem and make sure that it works. I'm going to take 8 to the second plus 15 to the second and see if it truly does equal 17 to the second power. So 8 squared is 64, 15 squared is 225, and 17 squared is 289. So 64 plus 225, it does equal 289. I think we've got the right numbers. Okay, that one was a lot of work. Okay, let's take a look at number 3. Given the diagram below, if the area of the shaded region is 59 inches squared, what are the dimensions of the outside rectangle? All right, let's talk about the shaded region. It is only this part that they had in gray that I'm now putting in green. Okay, so we don't want the whole rectangle on the outside. We want the area of the big rectangle, and then somehow we need to get rid of the area of the inside little white rectangle. So let's talk about this. Suppose that I had a large rectangle. I'm just making up a problem. And I said that it had an area of 100 square inches. And then I said that there's a little rectangle inside, and it has an area of 20 square inches. And then suppose that we want to talk about just this part. Do you know how we could find it? We could take the big area minus the little area, and that would leave the green shaded part. And I may have run out of space to write. There we go. Okay, so I'm going to write this down for us. Big area minus little area equals the shaded part. That might help guide our thinking. Okay. Over here, the big area could be found by taking length times width. So we could find the big area by taking x plus 6, notice the parentheses, times 2x minus 1. This would be the big area. And then we could find the little area, the area of the little rectangle, by taking its length times width, right? So little rectangle's area, this would be x times x plus 3. I could have put parentheses around that x, but because it was a monomial, was single term, I didn't need to. All right. Let's go ahead and solve each of these, and then we'll look back at or expand each of these, and then we'll look back and see what we get. So the big area is going to be x times 2x, that's 2x squared. X times negative 1, that's negative x. 6 times 2x, that's 12x. If I put these together, I will get 11x. And then we have 6 times negative 1, that'll be negative 6. There's our big area. Little area is going to be x times x, x to the second, plus 3 times x, that's going to be 3x. So there's our littler area. Okay, so we now have a simplified expression for the big area and for the little area. Now let's look back at the problem we were talking about. Before, to find the shaded area, we said take the big minus the little, and that leaves the shaded. If we take the area of the big one and subtract away the area of the small small rectangle, that will leave just the gray part left over, right? So we're going to take big area, 2x squared plus 11x minus 6, and we're going to subtract away the little area. Parentheses are especially important on this little area. When we subtract a binomial, it changes things. big area minus little area equals the area of the shaded region, which they gave us, 59. So this parentheses in front doesn't really affect anything, but this one certainly does. It's going to affect each of those terms. So essentially what we have is 2x squared plus 11x minus 6, and then we have negative x squared and negative 3x to equal 59. Let's simplify on the left. A negative x squared and a 2x squared, that's going to be 1x squared. 11x and negative 3x together, that's 8x. And then we have this minus 6 equals 59. Let's get this to standard form. So we'll subtract 59 from both sides. And I get x squared plus 8x minus 65 equals 0. All right, let's see if this one factors. So negative 65 is a times c, and then our b value is 8. So I'm looking for two numbers that multiply together to give me 65, and I divided by 5 right off the bat because it ends with 5, and 5 and 13 multiply to give us 65, and their difference is 8. So I need to make one of these negative. The one that I choose needs to be negative so that when I add them, I get positive 8. So I think it needs to be the smaller number. 13 minus 5 would be positive 8. So my factors are x minus 5 and x plus 13. These equal 0. So my solutions are what minus 5 equals 0, 5. What plus 13 equals 0, negative 13. All right, let's look back at the story. These numbers represent dimensions of these rectangles. Now notice that one of them has a length of x. Could that length be negative 13? No. Lengths, distances, those are not negative. So we're going to disregard that answer. And instead we're going to use x equals 5. They want the dimensions of the outside rectangle. So I'm going to come back up here. And if x is 5, then one dimension, 2x minus 1, that's going to be 2 times 5 minus 1. That one will be 10. Nope, sorry. 2 times 5 is 10. Minus 1, that will be 9. So one dimension is 9 inches. The other dimension, x plus 6, if x is 5, then it's 5 plus 6, that would be 11 inches. So we have a 9 by 11 inches. I don't know the best way to write that. Maybe I need to say 9 inches by 11 inches are the dimensions of the rectangle. Whew, this is a long lesson. We got one more. Here we go. Find 3 consecutive positive integers such that the product of the median integer and the largest integer is 72. Okay, let's talk about consecutive integers. What this means is we're taking 3 numbers that are in a row. So it could be like 1, 2, 3. Or it could be 25, 26, 27. Okay, these are 3 numbers that are in a row. Now, you may already be able to guess the answer, but I want you to work through the algebra because there may be a problem that you can't just know the answer. So you'll want to know how to solve it. If I'm going to write an expression for 3 consecutive positive integers, I would call the first one x, and then whatever that is, to get to the next one, it needs to be 1 higher than that, 1 more. So I'll say the next expression, the next integer could have the expression x plus 1. For instance, if this one were 5, then x plus 1, 5 plus 1, that would be 6, right? It would give me the next number. What do you think would go beyond that? What's going to be our third expression for the third positive integer? Did you guess x plus 2? Then if x is 5, we would add 2 to get it, and we would have then 7, right? 5, 6, and 7. So these are the 3 that we're going to use. This one represents the smallest number. Do you know what x plus 2 represents? The largest number. And this one is the middle number. So I don't know, medium, maybe we want to call it. Okay, let's read the story problem now and see what we can do with it. Find 3 consecutive positive integers such that the product means multiply, the answer to a multiplication problem. The product of the median integer and the largest integer is 72. Okay, the median integer is this middle one, so I'm going to multiply the middle one, notice parentheses again, and the largest, x plus 2, their product is 72. All right, let's solve this. X times x is x to the second power. X times 2 is 2x. 1 times x is 1x. If I add those together, I'll get 3x. 1 times 2 is 2. Let's put this in standard form. So I'm going to subtract that constant from both sides. We'll have x squared plus 3x minus 70 equals 0. I'm looking for two numbers that have a product of negative 70, but a sum of 3. Let's see, 70 divides by 10. 10 and 7 have a difference of 3, so these could be the candidates that we want. I need one of them to be negative so that when I add them, I get positive 3. And so that when I multiply them, I get negative 70. So I think negative 7 is the one we want. So we'll have x minus 7 and x plus 10. Now we want to find the solutions. What value minus 7 equals 0? It's 7. What plus 10 equals 0? Negative 10. Okay. The story problem was asking for 3 consecutive positive integers. So one of my answers is not possible. Which answer is wrong? Or which answer doesn't fit this problem, I guess. It's not wrong, it just doesn't work for us, the negative 10. So the solution we're going to use is 7. Since x equals 7, then I know my smallest integer is 7. What's the middle integer if x is 7? 7 plus 1, 8, right? And the largest integer, if x is 7 and we're looking at x plus 2, that's going to be 9. Are these 3 consecutive positive integers? 7, 8, 9, yes. And we can double check that they fit the story. Does the median integer, the middle one, 8, and the largest integer, 9, is their product 72? Yes. 8 times 9 is 72, so these fit. All right, good luck on this homework. Nice job.